Hello students, in this lecture we will study about data path and control considerations. Okay, the previous lectures we have already discussed about how addressing modes, condition codes will influence the instruction execution. Okay, so in this video we will see how a modifications is done to support a 4-stage pipeline in a 3-bus structure. Okay, so here we're talking about a 3-bus structure suitable for pipeline execution with a slight modifications. Okay, I will tell you about how and where the modifications will be done, okay, to support a 4-stage pipeline. Okay, or how a 4-stage pipeline is implemented by using a 3-bus structure. Okay, so let's see. This is a complete diagram of data path modified for pipeline execution with interstage buffer at the input and output of the ALU. Okay, so what the changes we have to made to run a 4-stage pipeline. Okay, as the 3-bus structure we are using bus A, bus B and bus C. Okay, so there are separate instruction. What are the changes? Okay, let's discuss about the changes. First, there are separate instruction and data caches that use separate address. Okay, here is data cache and here is instruction cache. Okay, at the same point of time you can compare it with a 3-bus structure. Okay, there is a 3-bus structure, but in the 3-bus structure we are adding some extra hardwares. Okay, and some extra modifications we have done so that it can run a 4-stage pipeline instructions. Okay, so what the modifications were attached a different cache memory for instruction and data cache. Okay, and the data connections also to the processor are different. Okay, as instruction cache is connected to this instruction decoder and data cache is through this MDR read and MDR write operation. Okay, so this requires two versions of MR. Okay, means memory address register. One is IMR and another is DMR. Okay, one is for instruction, another one is for data. As we are differentiate this instruction cache and data cache, so that we are using two memory address these registers, one for instruction and one for data cache. Okay, and it is one of the modification. And next second modification is the PC is here the PC is connected directly to the IMR. Okay, so that the content of PC can be transferred to instruction memory address register, this instruction fetch. At the same time that an independent ALU operation. Okay, that means PC cannot is here PC is not controlling the ALU operation. Okay, so directly PC is transferring, means let's where if we want to increment the PC by 4, then we may need the help of this ALU. Okay, so sometimes ALU may be busy for incrementing the PC, but here we are adding an incrementer. Okay, so PC value can be directly transmitted to MAR so that it can fetch the next instruction, and at the same point of time ALU can do some other work. Okay, okay, so this is the second, that PC is not connected with the ALU and PC is direct PC's content can be directly transferred to this IMR. Okay, so that ALU now independent to take some other operations. Okay, so and next one is the third one is the data address in DMR can be obtained directly from the register file. Okay, obtained register file or from the ALU. Okay, through this. Okay, that means data, this DMR means data memory address register, that is for accessing the data. It can access directly from the register or from the ALU. Okay, after the operations, arithmetic logic operations, it can also collect the data from the ALU directly. Okay, which it basically supports the register indirect, and another one is uh, index addressing mode. Okay, there is two addressing modes which it supports. Okay, as we know that indirect and index addressing modes have less side effects. Okay, and nowadays more number of processors using this type of addressing modes. So, and fourth one is here. There are two MDR registers, means memory data registers, one for read and another for write. Okay, so MDR register is one for read and another one for write. The means one is used for reading the data and one is for writing the data. Okay, so data can be transferred directly between these registers. Okay, and the register files during load and store operations without the need to pass through this ALU. What we have done in the previously defined 3 bus architecture. Okay, we have to pass it through an ALU, then we're storing it some registers. Okay, but here we can directly interact with the register files. It is a modified version of 3 stage architecture. Okay, we're implementing some new features, new concepts. Okay, so it is the fourth one, and fifth one is there are some buffer registers, as we have seen in before that especially in hardware control. In that concept where I have already told you about buffers, interstage buffers. In each unit, like in between fetch unit and decode unit, there is a buffer. In between decode unit and execution unit, there is also a buffer. Okay, so these buffers are called as interstage buffers. So these here is also some interstage buffers are there. Okay, so it is introduced at both the point, means at input side and also in the output side. Okay, so these are registers like src1, src2. Let me write it here: src1, src2, and okay, that means source 1, source 2, and result. These registers we have already used in operator forwarding concept. Okay, and this forwarding concept also applicable here if it is needed. Otherwise we can neglect that. Okay, and another one is the sixth one is, okay, what another one is, yes, the instruction register has been replaced with instruction queue. Okay, that means each instructions is loaded from instruction cache into instruction queue, then through the instruction decoder it is transported through these control lines. Okay, this is control signal pipelines. Okay. This pipeline holds the control signals in buffer B2 and B3. Like B2 and B3 means B2 is basically used to between decode and execute, and B3 is your like execute and write. Okay, B1, B2, and B3. We have already discussed it. Okay, so whatever I have told you, I have already make a note of it. Okay, I will provide it after some time. Okay, so let's discuss it again. The first one is there is two separate caches. One is data, one is for instruction, and also there is two MR we are using. One is for instruction fetch and one another is for data. Okay, and PC is connected directly to this PC is connected directly to this IMR, so that ALU it is independent and it can do any type of operations. Okay, other operations. This is, and the data address in DMR can be directly obtained from the register files and also from this ALU. That is third one, so that you can perform register indirect and indexed addressing modes. Okay, and another one is different MDR registers are used for read and write. and the transmission between these is directly connected, and it is also directly connected with the register files so that load and store operation can be performed. As we have discussed that if uh, only the load and store operation must have the capacity to access the memory. Okay, so to that happen we have modifying this. And next one is we are using the buffer registers, interstage buffer registers, like in operator forwarding we are using, that is src1, src2, and this is result. Okay, and another one is the instruction register is replaced by instruction cache, and each instruction is fetched from the instruction cache and then it is stored in the instruction queue. Okay, then after it will be transmitted to the instruction decoder. Okay, and the instruction decoder output is transmitted to the control signal pipeline. Okay, and also to this, if it needs somehow the help of PC or ALU or anything, it will be transmitted to that means the interconnection between these three bus architecture and control signal pipeline is our instruction decoder. Okay, so these are some modifications which we have done for pipeline execution. Basically the data path is modified, contents are not modified. Where we have transmitted the data, where the instruction will be transmitted only changed. Okay, and also main thing is that we have using this interstage buffers and two IMR, so two MR registers, two MDR registers, and the connection between PC and ALU. Okay, so these are some modifications. Okay, whatever I have told you, I make some notes. Okay, you can go through this. Okay, these are some notes. Okay, so there is 7 modifications have done. So there are some operations that can be performed independently in this processor. Okay, as instruction and data cache is different, so reading an instruction from the instruction cache is independent. Okay, and also incrementing the PC will not depend on the ALU. Okay, if ALU is busy, then PC has to wait for some time. So and here we can easily increment the PC, or PC can increment automatically. Okay, and decoding and instruction means instruction decoder is now a different path. Okay, so it has some independent operation. Another one is reading from or writing into the cache, into the data cache. That means we are using two MDR registers, okay, one for reading and one for writing. So reading and writing is not now, it is not dependent on each other, so independently it can be performed. Okay, especially in the data cache, means at a time you can read, at a time you can write. But in the previous, if anyone write before read, then it may read some wrong data. Okay, but here as two registers are there, so one is for read and one is for write, and reading contents of up to two registers from the register file. Okay, so there are, these are some independent operators which are performed in this type of processor. Okay, so this is all about data path and control considerations. Okay, some data paths, how data path is changed, how it is modified, it is shown in the previous picture. Okay, this is all about of today lecture. Thank you.